So for number 8, we're supposed to construct isosceles right triangle jib, given JI is a hypotenuse. So since we have, just thinking about this, we have a isosceles triangle with a 90-degree angle. That makes these two 45-degree angles. So that means, realistically, since they gave me JI and JI is my hypotenuse, they gave me a line and my two angles that come off that line. So what you're going to do is you're going to construct JI so this is my length JI. And then I want to create a 45-degree angle, and I want to paste it on both of these, and then they'd meet at a 90-degree angle. So what we had to do is off to the side, create a 90-degree angle, have it, so I can have a 45-degree angle. Oof, that was a pretty bad one. But life will continue because we're just trying to get through this. So we're going to have a 90-degree angle right now. Now I'm going to have that 90-degree angle. I'm just going to use this length. All right, to have it, we just need an X up here. My compass slipped like crazy. Finish that X. That didn't work out super well, but you should know how to half an angle. All right, now that I have that down, that is 45 degrees. I'm going to copy and paste this angle here. I'm going to copy and paste this angle here, and then I will have my 45/45s. So that means I need to copy this arc. We'll have the same arc here as we do here. Open the mouth of my 45-degree angle. Mark that. Mark that. And what I would do is I would shoot this up. Shoot this guy up. That was supposed to be 45, but I messed up my angle right here, but that's enough marks for me to give you full points for that drawing. So your job was to construct a line and construct 45-degree angles on either side. Yes?
And because it's isosceles right, both of the angles are 45. Because it was just a right triangle.
We wouldn't know otherwise. Yep. But because it's isosceles, both of our base angles have to be congruent. That's what makes them 45. Yes.
Oh.
Yep. If this would just say construct right triangle jib, we couldn't actually construct it. Because all we were given is a side and an angle, and you can't construct a triangle unless you have a theorem behind it. So in this case, we had angle, side, angle, so I can construct it. If you notice on every single one of these, they gave you 3 bits of information, and every one of those would have matched a theorem or a postulate that we know. Yeah?
And could JIB look like the one that you have in the upper right-hand corner?
Yes, yes, where you do the 45s going this direction. Yeah, yeah. I mean, just turning stuff, we can, you could have did it below, you could have did it at an angle. Yeah. Other questions? Yeah, Jamaria. Number 5, construct isosceles cap given that X is our perimeter and CA is our base. So the first thing I'll do is I'm going to construct the base. So let's construct CA. Let's call that C. And then we'll go out and we'll finish with A. All right, that's my length CA. Well, then the other thing they give us is our perimeter. Well, our perimeter is all 3 of our sides added together. So the first thing I'm going to do is I'm going to mark the length of CA on this line. Because I already used that. I can't use it anymore. This is my CA right now. Whatever's left are my other 2 sides. And since it's an isosceles triangle, both of those two sides must be the same length. So I'm trying to find the midpoint of this so I can figure out what each length is. So to find a midpoint, once again, we're going to bisect it by opening our compass past halfway, creating our little fishy shape of sorts. And then once I have this drawn, I have a midpoint. And so that midpoint will give me the length of both both my other two sides. All right, so that'd be CP and AP. So this would be basically CP, this would be length AP, then all three of those sides add up. So what we're gonna do then is we're gonna open our compass to get that length locked in. And I'll come to my drawing and I'm going to draw basically how far that side would come out. Do the same thing for the other side. And where they intersect would be my point P. I would take my straight edge and connect those, and we would have that triangle cap. So this was one where we had to realize they gave us side, side, side. They gave us what we needed, side, side, side. Every one of these is going to give you three things. You just got to figure out what three things they gave you. Is that good? Okay. Other questions? All right. Oh, yeah. Number 6. Number 6 is construct jazz, given that JA, where we have a measure of that. So we're going to go ahead and construct JA. I should actually construct it instead of just making it up. All right, so this one was, they gave me an angle, and they gave me a side. They gave me side, angle, side, or actually angle, side, angle. So what you need to do is you need to construct a 45-degree angle and put it there, and you need to construct a 75-degree angle, and you need to put it there. You don't have to do it all within the shape. So if I was going to construct a 75-degree angle, I might, off to the side, construct a 60-degree angle. To construct a 60-degree angle, you just have to have a segment that's a certain length. Come up. Come up. That's now a 60-degree angle. Well, to make a 75-degree angle, you have to do 60 plus 15. That's one way. There's other ways to do it. You also could do a 45 plus a 30-degree angle, however you want to. But your job is, I'm going to go ahead and create the 75 by, I guess, bisecting this one. So now I have a 30 and a 30. I'm going to bisect it again to get a 15. So now I have a 15-degree. Well, since this is 60, if I just take this 15-degree and add it on to here, I would then have a 75-degree angle. So that's exactly what I'm going to do. So in order to do that, I'm going to open my compass and actually extend this arc. So then the arc here will be the same arc as where I'm pasting it. So then I just have to open my compass to the size of that 15, add it on. And 15 plus 60 is going to be my 75-degree angle. So that right there is my 75-degree angle. So once we have our angles, we just copy and paste them. I don't have a 45. I constructed it before. So I'm just going to paste my 75-degree angle one, really quick. And then it would be your job to create a 45-degree angle and paste it on there. Yeah.
Would it work if I made a 90-degree angle and then bisected it and then bisected half of it another time and then got the 75?
So you did 90 and you bisected it, which would be 45.
And then I bisected half of it and then made a 15 and a 15.
Well, not with a 90.
Oh yeah, because
That'd be 22.5.
that wouldn't make sense.
Yeah, you have to do your 60 and then get your 15. If I was doing this problem, honestly, I would have created a 45-degree angle and pasted it. And then I would have created a 30 and added the 30 plus the 45, because then I'm not creating brand new angles. I already had a 45, I would just add 30 onto it. It's easier to bisect something once than twice a lot of times.
Okay.
Yeah.
So like, there was a problem like way back, and it was like, construct 22.5 degrees. So like, on a test, are we allowed to copy a 45-degree angle and then like bisect it?
Yes, you have to tell me where you copied it from, though.
Okay, so like, I would say like problem, like.
You'd say problem number 2, I already made a 45-degree angle. I copied it from number 2.
So like, is there a certain number we're only allowed to copy, or like?
No, if you construct an angle, you can use it as many times as you want on the test. Yeah.
If you use like 2 angles from the problem, do you have to like specify the angle that you chose, or just like?
Just say you got it from number 2, because I can figure out where you did a 45-degree. Now, here's the problem. If you created your 45-degree angle wrong, then every time you copy it, you're copying it wrong. So make sure you should know how to make a 45-degree angle. You should have made a 90 and then halved it. You shouldn't have some crazy, weird stuff happening. So if you know for a fact you created it correct, you can use it as many times as you want on the test. Just say where it came from. Yeah.
Me?
Oh, yeah, your hand was still up, right?
Are you gonna like measure our angles with the protractor?
Only if it's horribly wrong. I want to figure out where you made the mistake.
Oh, okay.
So if I'm looking for this to be my 75 and I get yours and it looks like this, what I'm going to do is I'm going to go back to where you constructed it and figure out where you made a mistake. All right, I'm not going to measure it I'm going to eyeball it. Most of me grading is eyeballing and making sure you have the marks.
Okay.
It's only when it looks hyper wrong that I'm going to start measuring stuff to figure out where you made a mistake, to figure out how many points you have to take off.
Okay.
All right, let's talk about today's lesson. Today's lesson is a bunch of words and triangles that will throw you off your game, basically. So we're not going to spend a ton of time thinking of these. How this is going to look on the test. Well, let's go through this first and I'll tell you how it's going to look on the test. So let's talk about an incenter. An incenter is the point of concurrency of angle bisectors of a triangle. So when you think incenter, I want you to think angle bisectors. Do we know how to bisect an angle? Yes. All I'd ask you to do is bisect all 3 of these angles and name the point where they intersect. That's how well you have to know what an incenter is. So that's how it would look like on the test. I would say bisect all 3 of your angles and then tell me what that point is where they intersect. Now, be ready. On the homework, your lines aren't going to look perfect. On your homework, you might have something that looks like this, where because you're doing your own thing. I bisected this one, and all of a sudden your third one's kind of up here. I'm not asking you to redo anything. Just know that these as long as you're close enough, it's fine. As long as you did your constructions and I can see all your marks, you're fine. It doesn't have to go through there. Exact same point. We're just getting it close, okay? So don't erase just because it doesn't look close enough. As long as they're close to making that point, that's good enough. In fact, a lot of times I'll just cheat it and put a big point over it and go, that's where they intersected. Okay, so I'm not looking for perfection. All I'm looking for is if I ask for angle bisectors, you should call that the incenter where they all meet up. We don't need to memorize this theorem or anything. It's just good knowledge.
So we don't have to write it on here.
Nope. We're not going to have a theorem sheet for this one. We're not proving anything. Like I said, on the test, all I'm going to ask you to do is draw 3 angle bisectors, name that point, you're going to call it the incenter. That's as much as we're going to need from that part. From this next part, we have a circumcenter. Circumcenter is the point of concurrency of the perpendicular bisectors. So on the test, it might look like draw all your perpendicular bisectors. Now name the point of intersection. That's when you're going to have to write down circumcenter. So circumcenter goes with your perpendicular bisectors. Do we know how to bisect a line? Then we know how to do this. I mean, if you think about it, when I'm asking for a perpendicular bisector, all I'm asking you to do is focus on the line, open your compass past halfway, create your marks below and above, create your marks above and below, because you need to have 2 marks for this one. And if you look at mine goes perfectly through that line. That's all I'm asking you to do for perpendicular bisector, is to do a perpendicular bisector. Guys, these aren't quizzes. You can look through your notes how to do a perpendicular bisector. I don't know why a lot of us just put all of our notes away and we're like, I need to memorize right now. If you don't know how to do this, you need to look up how to do that. So when I ask for a perpendicular bisector, you're going to treat each thing as just a segment. So I would do the same thing here. I'd open up past halfway. I'd mark that, and then I would do the same thing on this side. I didn't quite open halfway, but you get the idea. All right, and once I created 3 of these, that's called a circumcenter where they intersect. Our next thing is altitudes. Where your altitudes intersect, that's called our orthocenter. We'll talk about constructing an altitude in just a little bit. So altitudes go with orthocenter. And finally, medians. Medians go from a vertex to the midpoint, is going to be called your centroid. So you do need to know these words. So when I ask you to create this on a triangle, you can then name it. So once again on the test, I might say, draw all your altitudes. What's the point of intersection? That's where you have to say orthocenter. Nope. You don't have to know all of this stuff either. We're just looking for these words. So when I say draw your altitudes, you say orthocenter. When I say draw your medians, you can think centroid. Are we good with that so far? Yes.
Wait, so like the altitude is the one where it just like makes a 90 degree angle?
Yes, and we're going to go over that right now too. All right, so let's talk about this. So you need to know how to do 4 things with a triangle. The first thing is your median. Your median is the segment from the vertex to the midpoint of the opposite side. How do you find the midpoint of a segment? Yes.
Make a perpendicular?
You make a perpendicular bisector. So this one requires you to make a perpendicular bisector. Well, we need to make a perpendicular bisector for the perpendicular bisector as well. So by making a perpendicular bisector, you're going to help create a median and a perpendicular bisector. So these two are going to be almost identical. It's just how you finish the problem, and I'll show you that in just a second. All right, but these two are going to be identical on how you do them. Altitude. Altitude is the perpendicular segment from a vertex to the line that contains the opposite side. We're going to do that next. Angle bisector. Do we know how to bisect an angle?
Yeah.
We're not going to show that in class. You're just going to have to know how to do that on your own or look it up. We did that a whole bunch of times. We're going to do these 3 right now together to make sure we know what's going on. All right, so the first one we're going to do is we're going to construct altitude BT. Now remember what an altitude it is. An altitude needs to go from B straight down, create a 90-degree angle. That is your altitude. Well, what I want you to think about when I ask for an altitude, forget about these lines. Think about a point and a line you need to drop a perpendicular through. That's called raising a perpendicular. Yeah? We make the tick marks. We need to make a tick mark to the left of that imaginary line and to the right of that imaginary line. I'm going to tell you right now, sometimes it's going to be hard to make a tick mark. You may have to extend the other side so you can actually see your tick mark. It's going to work on this one. So I'm going to make a mark to the right of it. Keeping my compass that same measure, I'm going to make a mark to the left of it. Remember, I'm just picturing this imaginary line. I need a tick mark to the left and to the right of it, and both of them have to be equal distance from that B. All right, once you have those two sides, now all you have to do is open your compass past halfway. Do we already have a point we can use? Yeah, we have B, so that means I just need one X, right? So we can either do an X on up here, we could do an X down here, or we could do the full thing. I'm just gonna go ahead and make an X up here. Like I said, you could have done the X down there as well. All you're gonna do is you're gonna connect that vertex through that X, stop at the line, make a 90-degree symbol, and also put a T there because it does say it's supposed to be segment BT. Yes?
Can you put the right angle on both sides?
Yes, you can absolutely put it on the right side. But remember, one tells you that all four of these would be. Yeah. All right, that's how you construct an altitude. The next thing we're going to do is we're going to construct a median. I'm also going to construct an angle bisector because that's what, or a perpendicular bisector because that's what I have to do first. So remember, median means midpoint. It means midpoint. I have G to the midpoint, so I need to create a midpoint on EF. The only way to do a midpoint is to use a perpendicular bisector. Remember, to do a perpendicular bisector, do I have a point yet in the middle? No, so I have to create two X's. I need to create one above and below. So in this case, I'm going to open my compass past halfway. And I'm probably going to do it kind of lightly. I'm going to spin my compass. And you don't need to make the whole thing, you just need your X's. I'm just going to spin it for effect. Can we all see my two X's? So when I connect those, I actually created a perpendicular bisector. Oh, I should probably have a C in there. Bisector. So if this question asked me to do a perpendicular bisector of EF, I'd be done. Does it ask for a perpendicular bisector? No, it asks for a median. A median means I'm going to put a point on the perpendicular bisector because that is my midpoint. And it says I'm supposed to make GM, so I'm going to make that point M. And then all I have to do is connect G to M. And that becomes my median. So when you create a median, you first have to do a perpendicular bisector. Yes?
Can you show how you did the cross lines?
Yeah, it's just doing a perpendicular bisector. It is just opening your compass past halfway, rotating it, open past halfway, rotating it. All right, so I have a perpendicular bisector and I have a median. But it asked for the median, so I'm going to highlight that. So just so you know, I just did two things. We did an altitude together, we did a perpendicular bisector, and a median together. Yes?
The one from up, the one on the end of the, like end, you know, like on the bottom, down by your phone, down there, you know? No, I'm not. Like, in between E and G, the end of the line, you know?
Okay, E and G.
Like, the end of the line that you made, that, yeah. Yeah, no, yeah. Is that also like the midpoint?
No.
Of that?
No.
Yeah, I mean, it doesn't look like that, so
No.
that makes sense.
No. How I'm going to know it's a midpoint, Michael, is I'm looking for this mark right here. If you have these marks and a line, that's going to lead to a midpoint. So in order for this to be a midpoint, I would need to see kind of that shape or the two X's. Okay? All right, other questions? Yes?
So like the perpendicular bisector we made is supposed to be the mid. It's not supposed to be the midpoint.
It is the midpoint. That's what perpendicular bisector means. It's perpendicular and it bisects the line.
Mine isn't equal though. Like mine has like a little bit that like it's not exactly.
Your compass probably slipped a little bit. All right, we're going to go ahead and construct altitude dr. We're going to construct altitude dr because it's the hardest altitude to construct. And that's because, does my line look like it's a 90-degree angle on the other side? No, it doesn't. And there's nowhere on here for me to create that. So we have to remember that we can extend this bottom line. We can extend this bottom line in any direction we need to. So now when I'm looking at D to R, so from D to down here to create a 90-degree angle, I'm looking at, well, about here would be 90 degrees. But I'm no longer allowed to eyeball it. We have to drop a perpendicular. So we need to make our marks to the left of D and to the right of D. So that means you are going to open your compass and you're going to try to make a mark to the left of where the line through D would go and to the right of it. Then you're going to open your compass past halfway and you're going to make your X. We just need one X because we already have point D. I just need another point to figure out where it's going to go. I'm going to, once again, I'm just going to put it on the top here. And we have a 90-degree angle, and we're just going to mark this as R. That's all you're going to have to do for this homework. So once again, I told you, there are only a few skills you need to have. The better you are at them, the make this stuff becomes a lot easier. You have to know how to copy an angle. You have to know how to bisect an angle. You have to know how to make perpendicular lines. And you have to know how to bisect a line. Yes?
When you're marking the marks like on line RE
Yep.
for the altitude, does it have to?
Shh. I can't hear her. These two marks?
Never mind.
You sure? Yours matches mine.
Yeah, never mind.
Okay. Mike, do you have a question?
Yeah, I just can't see that one.
You can't see which one?
No, I didn't, the one that you just did 3.
Okay. You have questions how to do it? All right, so we need to extend this line. Did you already do that?
Yeah.
Okay. Then we need to drop a perpendicular through D, which means you need to open your compass to some length, make a mark to the right and to the left of it.
Yeah, okay.
And then open your compass past halfway to create that X on the top. Yep. I can't stress you have to know these basic skills very, very quickly. Yes?
Do we have to draw the circumscribe or inscribe circles?
No, we're not doing that. Because we cut that out because we added a stats unit at the end of this. So we cut a bunch of construction and proof stuff out so we can have stats at the end of the year.
What does that mean?
Testing.
Graphing?
What was that? All right, just real quick. So make sure you know these basic skills. On the test, you are going to run out of time very quickly if you can't rapidly copy angles, bisect lines, and create 90-degree angles. But those last two are the exact same thing. And I guess copying and pasting lines, but you should know how to do that. So if you are behind, like I keep saying, you need to practice these skills. And you do have a website that shows you how to do every one of these things. You can just watch them over and over and over and practice them over and over and over. Otherwise,